Today, we present our product innovation title, Dynamic Voltage Restorer, for complex power quality mitigation, in microgrid, with photovoltaic system. The decarbonization of electricity production is the new era of developing power systems, with increase of multi-voltage level installation of renewable energy sources. The demand for good power quality has increased, with increased energy demand, along with future economic development, and, to perceive healthy communities. The continual energy or power supply is an essential need. The purpose of microgrid distribution automation is to reduce the emission of carbon dioxide by using renewable energy source to meet the energy demand during daytime. When excessive renewable energy is available, like solar energy, a robust and efficient fault analysis methods can be developed. To solve real-time distribution network faults and hence, we can control the climate change and save the environment. Associate Professor Murtadha is the Director of Solar Research Institute at University Technology Mara, Malaysia, in collaboration with Malaysia Comprehensive Energy Solution and Technocentric Solutions, has a goal to develop sustainable and optimized energy system to solve world energy crises by mitigating poor power quality issues with renewable energy resources, with use of advanced energy systems. Access to electricity in most parts of the world. So it may come as a surprise to learn that 16% of the world's population, an estimated 1.2 billion people, are still living without this basic necessity. Lack of access to electricity, or energy poverty, is the ultimate economic hindrance as it prevents people from participating in the modern economy. Power quality issues or harmonics pollution is increasing regularly on the utility side by wide variety of nonlinear load applications connected with the integrated grid. Continual energy supply is essential need in places like hospitals, factories, transportation, and defense systems. Therefore, DVR is an efficient and effective solution with lower installation cost, smaller size, and fast dynamic response to the electrical disturbances. Additionally, DVR with PV system is a suitable sustainable energy solution investment that can be installed at any facility with long-term financial benefits. The proposed technology supports United Nations Sustainable Development Goals. Most of the power interruptions and poor power quality issues are faced by underdeveloped and developing countries, due to the lack of enough energy resources to meet the energy demand. Renewable energy is the best solution to meet energy demand at location where standard electricity is inaccessible. And dynamic voltage restorer with renewable energy resources is a cost-effective solution to mitigate complex power quality issues conveniently. And according to International Renewable Energy Agency, in under 20 years, the global energy-related carbon dioxide emissions budget to keep warming below 2 degrees Celsius would be exhausted. And the renewable energy shares in the total final energy consumption intensity projections, based on IRENA analysis, would increase significantly in future. Perhaps, the renewable energy transition can greatly boost overall employment in the energy sector. Along with the adoption of emissions mitigation paths, will result in stranded assets worth more than $11 trillion. In addition of mitigating power quality issues, the DVR system can also be used for energy saving by reducing real power and reactive power at allowable voltage level injected into the three-phase system. This feature makes it a world's first power electronics device for commercial, and especially for domestic users, as an energy compensation device that can be used by any type of renewable energy system for energy saving and electricity cost reduction. These are some of the key companies operating globally in energy storage systems and power grid market, who will be involved to adopt the proposed DVR technology to implemented voltage regulation device with external energy storage device to support utilities and commercial power distribution systems. In reliability, the utility companies will be interested to purchase the proposed technology to avoid from system collapse that is useful for economic security of the country. To test the concept, MATLAB Simulink modeling is used. In a case study, a 100 kilowatts PV array is connected to the utility grid, that is also providing electricity to the sensitive load at remote location through a DVR system. The sensitive load is either operated by utility grid, or PV system depending on the energy demand rate to conserve excessive energy generated by PV grid. And DVR system eliminates any unsymmetrical faults during harsh weather conditions, and turn as a microgrid during total power outage. In this configuration, a PV array is connected to a booster converter to regulate voltage up to 500 volts by using MPPT controller. This DC voltage is converted to low AC voltage level of 260 volts, which is again boosted to AC 25 kV by a step-up transformer to feed the PV generated energy into the utility grid. A second step-down transformer is used in between PV grid and utility grid network that converts high voltage level to low voltage level of 415 line-to-line voltage to drive load. For this case, a battery as energy source is connected at DC link of the DVR inverter, that converts DC to AC voltage whenever the fault is detected. The compensating voltage is injected by series connected injection transformer into the distribution line through a passive filter. The The DVR system Simulink model is presented. Based on Simulink modeling, this is the actual hardware developed in the lab representing all the components used. And this is the hardware testing phase using DSpace controller and graphical user interface to monitor load and source voltage profiles. The results of load voltage compensation after mitigation are presented, where it can be noticed that DVR is able to drive load voltage during fault with above 90% to 98% of nominal voltage. And the THD percent is reduced to less than or close to 5% as per IEEE 1159 standards, and hence, energy savings in terms of real and apparent power is up to 16%.